Hello again. So today we continue our study of using text files using sequential access. And last time we looked at how to write text files. Today we're going to look at the second part of that problem, reading text files. Obviously, when you write data to a file, you write it to a file for later use, and use means reading from it. Now, you can always open up a text file and look at it in a text editor like we already did. But if you have a very large file, you may want to process the data in it using another program. And that's what we're looking at today. So what we'll do in a sample program that demonstrates read access of a text file, we'll use the same file that we wrote in the previous exercise. The code, the slides referred to it as clients.dat, but I think we called it client.txt in the source code. So you're already familiar with the different file opening modes. Last time we used the write mode, and we also explored the append mode. Today we're going to use the read mode using the R flag. Now the program is in some ways structured very similar to the program that we used for writing to the file. We have to begin by opening the file, opening it using fopen, which returns a file pointer, which we'll again store in a file pointer called cf pointer. Again, if the opening of that file, even though it's for read access this time, if it's successful, the fopen function will return a value to cf pointer that should not be null, and we'll check for that. After that, the program will read the different records written into the clients.txt or clients.dat file. We are referring to each line of the text file that we saw last time. We are referring to each line as a record. Remember, each record consisted of an account number, the name on an account, and the balance in that account. The account number was, just as a reminder, an unsigned integer. The name was a character array, and the balance was of type double. Now, to read values from a file, we use the fscanf function, which is kind of similar to the scanf function that we use to read input from the standard input. The main difference between the fscanf and the scanf function we're already familiar with is that the fscanf function takes one additional argument, and that is a file pointer, of course. The scanf function knows that it is reading from the standard input, the keyboard, by default, but the fscanf function has to be told from which file to read. Now, when the program will reach the end of the file is closed and the program terminates. FEUF, or file end of file, returns true only after the program attempts to read a non-existent data entry from the last line. And here's the source code that I will also show you. And I'll show you two versions of this. This version that you see over here, which is written in using the functions fscanf and fopen from the standard C library. And I'll also show you a secure version using fopens and fscanf_s. So as you can see, the start of this program is very similar to the one in the previous example. We declare a file pointer, CF pointer. We attempt to open that file, this time in read mode. And as long as this CF pointer is, if it's equal to null, it means something went wrong, the file couldn't be opened. We print out a helpful message saying that file could not be opened. And that takes us out of the if block, across the else block, and to the end of the program. If the file, however, is successfully opened and CF pointer is not equal to null, and all of this is happening in the if condition, that takes us into the else block. So if CF pointer is not equal to null, we enter the else block. So notice that for proper functioning of this program, we need some part of the code to execute in the if condition, and for the remaining functionality, we need the code in the else block to execute. So that's a little interesting and something you should note. Okay, so you enter, if the file is successfully opened, we enter the else block. We declare and define unsigned integer account, character array name of size 30, and a double precision floating point variable called balance. We print out a nice little header on top, account, name, and balance, just these three strings. We format them nicely, make them left aligned based on this minus flag that you can see over here. And then we call the fscanf function, and we read from the file we just opened, pointed at by CF pointer. And remember, the format that we used to write into that file is we wrote the account number, followed by the account name, and finally we added the balance in that account. And we read these three values into account, the unsigned integer, the character array name, and the double precision floating point variable balance. So fscanf works just like scanf, with the additional argument of CF pointer, the file pointer, because it needs to know which file to read from. And we then have a while condition that continues as long as we do not reach the end of the file. And what we do is, because in this program, we're just reading from the file, we print out these values, account, name, and balance. We print them out to the screen using printf. We format those three values nicely, and then we read the next value and go back up the while loop, print them out again, and so on until we reach the end of the file, which takes us out of the while loop. We close the file that we've opened for reading. We close the file CF pointer, and that ends the program. And depending on what's in the clients.txt file that you're working with, you'll see the output looks something like this. Now there's one other thing that I want to talk about, and that is, as you can see over here, we started reading contents of the file from the start of the file, and we went all the way to the end. And that's it. We went through the entire file once. But what if we have to go through a file again and again, searching for specific type of data? Well, for that, it is helpful to know how to move back and forth through a file. And for that, we need to know about something called the file position pointer, and how to reset it, how to move it back to the start of the file if needed. So to retrieve data sequentially from a file, usually what we do is, like I said, we start from the beginning and we move on byte by byte towards the end of the file until the data that we're looking for is found. Now, again, It may be necessary to do that several times because you may be looking for several different data entries and you may only be able to search for one at a time. In that case, it's necessary to go back to the beginning. So you can think of the file pointer kind of like the position of your finger when you're reading through a book, right? The position of your finger as you're reading indicates the current position that you're reading at. Similarly, file position pointer tracks the current position at which you're reading from or writing to a file. So you can think of it a little bit like this. So this blue arrow that you can see over here, that would be the file, representing the file position pointer. Now, usually when we read through a book, or we just read through it once, we just keep moving forward. But when we're working with files, sometimes we have to move back, we have to move forward, we have to move to the end. So it's a little more complex than that. But how to do that? Well, how to move back to the beginning of a file, how to move the file pointer back to the file position pointer, back to the beginning of a file. It's actually quite straightforward. We have a function for that called rewind, and it takes as argument the file pointer, and that's it. And a simple way to think about the file position pointer is simply as the byte number of the file that you're reading at. So the very first entry, the very first piece of data, the byte of data in a file is byte 0 of that file. As you read along into the file position pointer takes on integer values. So really this file position pointer, all it is, it's just an integer value. And it specifies, it's just a count of the byte number of the data in the file that you're reading at, or writing to. So if you have to jump back to the beginning of the file, all you have to do is call the rewind function and pass it the file pointer as argument. The file position pointer also has another name. It's also called file offset, which also makes sense. The file position pointer is an element in the file structure that I talked about a little earlier that is created every time you open a new file in your program. So as a demo, let's write this simple program called the credit inquiry program. It works with, for simplicity, it works with a file of the same format that we've been using so far for all the file exercises. And what this program will do is it will go through the file and search out records that match a certain criteria for you. And for this program, we'll keep it very simple. We'll have 3 types of records. We'll have customers that have a negative balance. We'll have customers that have a positive balance. And we might have customers that have a 0 balance. And what this program will do is it'll open a file, same way we've done so far in the previous 2 examples. And once the file is successfully opened, it will give users a menu like this. Enter request, and then you'll have 4 options. And so this is basically this is a menu-driven program. You have kind of like you see at an ATM, and you can then get to enter, the user gets to enter one of these 4 numbers, 1, 2, 3, or 4, depending on what the user wants to do. Do you want to list accounts with 0 balances? For that, enter 1, hit enter. You want to see accounts that have credit balances. A credit balance is a negative balance. It's kind of like credit card, right? You can remember it like that. Whenever you use a credit card, you're basically taking a loan from, taking a loan from the bank. So so we have 0 balances, we have negative balances, and then we have debit balances, which means having a positive balance associated with an account. And if you want to exit the program, you just want the user to enter 4 and hit enter. And the option that the user chooses is taken in using the scanf function stored in request, which is declared right here. And as long as that request is not equal to 4, is not a request to exit, what do? Well, we declare these same 3 variables we've been using so far, account, balance, and name, and we call fscanf, just like we did earlier, to read one record from the file. And then what? Then we have a switch statement over here that, based on what the request is, will perform some action on that record. So if the request was 1, that means list accounts with 0 balances. So just print out this string over here, and we have a while loop. And in that while loop, remember, we've already read one of the records from the file. If the balance for that happens to be equal to 0, we print it out to the screen. And then we read the next record from the file using fscanf. And remember, all of this is happening inside a while loop. We go back up here, and as long as that new record that we read in is not end of file, and if that balance is equal to 0, we print that out again and again and again, and so on, until we reach the end of the file and we jump out of the while loop and break out of the switch statement. If the user entered option 2, request 2, means user wants to see credit accounts with credit balances, negative, less than 0 balances. And we do this exact same thing over here that we just saw over here for request 1 for 0 balances. The only difference is on this line, the condition. We print out records that have a balance less than 0, negative. And guess what? If the entered request is 3, meaning user wants to see accounts with debit balances, then the if condition in the while loop is set to balance greater than 0, meaning the balance is a positive number. But as for the rest, this is almost the exact same code, with the only difference being here in the if condition. When you get to the end, we call the rewind function on the file, and we print out a prompt, a question mark on a new line, and we wait for the user to enter a new request, 1, 2, 3, or 4. And as long as that request is not 4, we keep going into the while loop. We keep doing one of these operations, case 1, 2, or 3. And when 4 is entered, that takes us out of that while loop based on the value of request, prints out end of run, closes the file, and ends the program. So this just describes the operation of that program that I just explained on the source code. This is just explained over here again. So we have these 4 options in the program. Option 4 terminates the program, and 1, 2, and 3 list either accounts with 0, credit, or debit balances. And this is what a sample run of this program can look like. So the options are printed out once, user enters 1, and it'll show you balances, accounts with 0 balances. If you enter 2, it'll show you accounts with negative balances. If you enter 3, it'll show you all the accounts with positive balances. If you enter 4, it'll exit the program. One thing that you have to remember with sequential files is that making certain kind of changes can be risky, can destroy data that comes after the data that you're modifying. So for example, if you had an entry in there and the name entry in one place is white, the name white, and you want to change that to something like this, Worthington, a much longer name, that will be a problem because this Worthington is a much longer string than white, which means once you hit 1, 2, 3, 4, 5 characters, 1, 2, 3, 4, 5 characters, anything that comes after that will overwrite data that comes after white in the file. See, that's not something you want to do. If you have to remove a record and add a new one, it's simply easier to read all the records you want to keep from the file and add a new record and basically do all of that in a new file. So yeah, careful with that. So as a rule, if you want to modify, not append, if you want to make a change in the middle of a file, instead of making the modification, oftentimes you'll end up having to rewrite that file, kind of make an updated copy of the previous file.